people will come in, but
Right. So
this is
if people introduce themselves, then that will allow people time to join.
that's a great idea. Okay,
Okay,
so
you can
do you want
start.
me to introduce you first?
Sure.
Sure. Okay.
Well,
Um,
you can introduce me last because then if
okay,
other
I'll do
people
you.
join.
Okay, so I'm Sue Glenn. I teach ecology, environmental science, and economic botany here at Rowan College in South Jersey. And this World Classroom series has been an idea that the Dean, Christina Nace, and I had put together as a way of sort of, since we were all being forced online, to realize that there's advantages to that. So there's no way we could have gotten our speakers to come down to visit us. And yet we've been getting one or two speakers every week to come informally to visit us on Zoom. So that's an advantage of being online that we wouldn't have had with the face-to-face classes.
Correct.
So I think in order to make the speaker more comfortable, if anyone's willing to put their cameras on, that would be great. If people are willing to chat, that would be really nice. And otherwise, we can certainly read questions as they pop up in the chat
Right. So why don't we
section.
start with Kira and tell me who you are and what you're doing?
Hello, so my name's Kira. I'm a cellular and molecular bio major at Rowan University. My goal is to work with genetics. So I'm not entirely sure where to go with that one yet, but I'll figure it out.
Okay. Well, we're doing a lot of work with genetics. We're in fact doing the whole genomics of an entire species because there's only 3,000 left on the planet. Devon, how about you?
Hello, my name is Davon Dixon. I am a team coordinator here at Rowan College of South Jersey for the Internship and Career Planning Division. I'm also a grad student at Rowan majoring in higher education with a concentration in administration. I'm here to learn more about environmental science. I find it very interesting and fascinating. So I'm eager to learn.
Sounds good. And Elaine?
Hi, I'm Elaine Dean. I'm the career tech specialist at Rowan College, South Jersey, and I also teach marketing. And I'm helping out Dr. Nason, Dr. Glenn with the World Classroom.
Excellent, excellent. Anthony, turn on your picture and tell us who you are. Anthony Haddad.
Might be away from his microphone right now. He's working on it.
I see a screen there that says Rowan College.
I'm here.
One
Hi.
second.
There
There you are.
Sorry, I was.
Good morning, everyone. My name is.
Anyway, I just wanted to say hi. I'm Bruce Myers. I teach anatomy and physiology, and I'm really interested in listening to Dr. Rubenstein because I went to school in undergraduate school with another biology major who ended up working for years overseas with tigers.
Oh, wow. Okay.
Tigers
Well,
and stuff. Worked for National Geographic, actually. And
wow.
I think it was tigers or cougars or something. I mean, I actually lived with them practically. Or
Oh, that's
something.
cool. All
I
right,
always
good.
find that interesting that he did that because
Well, I'll tell you about
he
zebras
decided
today.
he was going to live on his own in the forest and he passed out because he couldn't eat anything. But anyway, he lived with tigers.
Okay, great. Now, Anthony, tell us who you are.
Good morning. My name is Anthony Haddad. I am with the STEM division, cybersecurity, and I'm just much interested in the presentation, and I'm looking forward to continue learning and growing in any specific area. So I'm excited about it.
Sounds good. Caitlin. Caitlin Insana. You're muted. I can't hear you. Okay, we'll move on to
She's
Christina
on.
Nace.
Yeah, she's trying. I think she has trouble sometimes with her microphone.
Okay.
Yeah, sometimes it doesn't work.
Oh, now I hear you. Good. Hi, Caitlin.
Hi. I'm Caitlin. I'm a bio major, and I'm probably gonna switch to molecular and cellular biology because I want to work with genetics as well.
Okay, good.
Yeah.
Christina Nace.
So I know she's in a simultaneous meeting. she's the dean. So she texted me. She's also in a meeting at Teams right now, so she'll be
Okay.
in a few minutes.
Okay, Diane Gilson.
I'm here. I'm just having microphone issues this morning. I'm good now.
Good. Hi.
I'm an adjunct at Cumberland for the moment. I'm teaching a 102 course, so I have chemistry students who are also taking bio and other courses. And I also work on the Gloucester campus in the chem prep.
Sounds good. Thank you. Christina, she's not here. Emily? Emily Bunch? Okay, how about Hannah Joy?
Hi, I'm Hannah Joy. I'm an environmental engineering student at RCSJ.
Okay, very nice. Thanks. Chloe?
Hi everyone, I'm Chloe Benson. I'm math faculty at the STEM division.
Very good. And Brendan Rickards.
Hi, how you doing? I'm Brendan Rickards. I'm the provost and vice president at RCSJ, and actually an alum of Princeton's molecular biology department. I was actually on the panels that they did yesterday also. I don't know if you saw any of those, but I was one of the alumni panelists yesterday. So how are you?
I'm fine. I missed that one. I was busy with our departmental seminar speaker, who is an anthropologist talking on Madagascar during that.
I remember all of those. I remember all of those as well. I did talk about that with some of the students as well.
Okay. Anyway, great. Okay, so that's everybody that has spoken up. So you can introduce me, Sue, and then we can start.
All right. Well, I'm really pleased to introduce Professor Daniel Rubenstein. He is joining us from Princeton University, or full professor at Princeton, and also in charge of the director of the environmental studies program there. But I invited you to come today because of your research in ecology and to try to find out sort of what got you to where you are, and maybe give us some advice to some of the students and answer some of their questions.
Okay, so so what I've done today is I put together a PowerPoint. Can I share my screen now?
I think you should be able to.
Okay, let me see if I can grab it. Okay.
Yes, I can see it.
Can people see it? Okay, let me go to full screen. Okay, so I'm a field ecologist and animal behaviorist, and a lot of my work now connects science to society. And so what I'm going to do is sort of give a history of how I started and why I think it's so important that we as scientists take our research and apply it by bringing people into the study of science to democratize science and make everybody a wiser decision maker, whether a science practitioner or not, in using evidence to make decisions that affect our connecting to the environment and to each other to do both environmental and social good. So I entitled the talk, Science and Society, Creating Knowledge, that's the pure side of doing research, and using it for environmental and social good. And so if we start out with science is one way of knowing, the humanities have a way of knowing, social science has a way of knowing, but the natural science has a way of knowing, and it's really about solving puzzles in a systematic fashion. It identifies patterns, and then from patterns, we dig into processes. And it doesn't matter whether we're field ecologist or molecular biologist, we use this very disciplined method. We peel the onion, so to speak, in the sense that we see a pattern, we take what we know from the literature about past knowledge, the givens, and we strip that away. And then we ask what's left that we don't understand. And then we look at mechanisms. And we often then look at the consequences of our understanding. So it starts with insightful questions. And when I do my teaching with my students, either in class or in mentoring, my goal is to teach students and colleagues how to ask questions that get at the heart of the problem. And this is how you create new knowledge. Now, initially, this was performed by naturalists and ordinary people, and I put up here Gilbert White's Natural History of Selborne because it really is perhaps the first book in ecology published in 1789. And it was about looking at the number of breeding birds in the parish church, in the area around the parish church. And he noticed that the numbers were constant, and that puzzled him. Why would they stay constant? Why didn't they increase if everyone was having babies? And that's really getting at the process of density dependence and competition. And so the pattern led to an understanding of mechanism. So originally it was performed by people who were ordinary citizens, often pastors who had time on their hands as they looked around the world, looked at the world around them, and we call them naturalists. But it eventually became the domain of professional experts because it required more details on theory, and it required more disciplined approach to peeling away the onion, so to speak, getting at the dynamics that were getting harder and harder to look at. And so the techniques and the tools became more technical and more professional. And so as expert scientists started to dig into the problem, science and society went their separate ways. We started to having this elite class of experts who started to look at problems, and other people still looked at the world in a romantic way around them, and periodically they connected to scientists. And so this has gone sort of out of favor. If you look at Richard Louve's book, The Last Child in the Woods, it's about saving our children from nature deficit disorder. Too often, children in school are getting cookbook science. They're not really discovering the world around them any longer. They end up looking at the world through the lenses of their teachers, who provide disciplined approaches to studying phenomena. So they become good at measuring things. They become good at comparing what they found with what's in the books, the textbooks that they read, but they never really personalize the science by asking good questions. And we've seen more and more professionalization of the storytelling that comes out of science by the professional class of scientists through the wonderful TV shows that we all see on nature, especially the BBC. You have a vicarious virtual experience has increased, but does that really lead to an understanding of what's going on? And I would argue that better science storytelling is not enough. While it provides wonderful images, and it provides a story that connects phenomena with mechanisms and process and tells the implications of that understanding, it still leaves people disconnected with the real world around them. And so my goal is to anneal these separate ways that the people look at the world remotely, experience nature in a vicarious way mostly, but then also in a romantic way when they go for hikes. They don't really learn how to ask questions compared to the scientists that are actually doing the digging into science. And so I want to make everybody a participatory science. We used to call it citizen science, but that has a pejorative meaning because not everybody is a citizen. But everybody can be a participatory player in understanding nature. And my goal is to have people, whether they're school kids or their teachers or you as students starting careers in science, learn how to do real science. And so there's a series of connecting entities. They have the Citizen Science Association, which has meetings. Earthwatch is a way that people can go travel the world and work with scientists in the four corners of the planet. Operation Wallacea is another one by Britain where students can plug into research by principal investigators, carve out a piece, and do an honors thesis based on that. So my sense is that what we have to do is we have to teach people to appreciate how science is done, to understand and participate in generating new knowledge, because that's how you really learn how science is done, and then understand this knowledge so that you can help shape future investigations. So you're not just a passive player, you become a participant to say, well, my reading of the story and the data is, and therefore, why don't we ask the following question? That brings the participatory scientist into a level playing field with the professional scientist as a true participant in framing the next question. And in that way, you become a better environmental steward and decision making in your own lives and for the lives of others. And I'm going to talk about 4 vignettes, 4 public programs that I've been involved in. One is the Scout program, which works with communities in Africa who live on a landscape that shares the land, the grass, and the water between their livestock and wild species, in particular zebras that I work on. Bio-Blitzes, where we bring the public into participating with measuring and understanding the dynamics of populations. And we do that again in Kenya with what we call the Great Grevy's Rally. We'll also then look at our intersection of science with the school kids in Kenya, our conservation clubs, and I'll end with then working with teachers locally in our local high schools that provided you with your fundamental education as a feeder before you've gone off to college and university. But first, some background. First, as I've noted, science is a continuous process. It creates new knowledge over and over again, and it identifies pattern and then searches for causes and consequences. And so a lot of my work has been on the equids, which are the horses, zebras, and wild asses. And there's only 7 species left on the planet. And they're not very populous because they're often considered vermin, which is what I'll talk about next, because they eat the same vegetation that people that make a living off the landscape with livestock, they would prefer those grass blades and that forage in the bellies of their animals because that is how they produce meat and make money by doing so, or produce milk and provide protein for their children. Now, a lot of my work as a behavioral ecologist, which means I look at how the environment shapes behavior, is about understanding how animal societies form. And of the 7 living equids, the plain zebras, the mountain zebras, the wild horses, and the domesticated horses that have gone feral, they all show one type of social system, whereas the Grevy zebras, the Asiatic, and the African wild asses show another. So we'll start with the plain zebras and the wild horses and the mountain zebras and the feral domestic horses. Their society consists of family groups that are closed membership, which means that the males and the females stay together for long periods of time. And our data shows, like in zebras, that on average, a male and his female stay together uninterrupted with no comings and goings for about 3.5 years. Some can last 18 to 20 years with no change, and others change more frequently. But they are long-term bonds between the males and the females. These lead to what we call so-called harem groups, one male and many females, because it's a society in which the females are monoandrous, they mate with him, and he's polygynous, he mates with many females. And each one of these family groups has a home range, and the home range overlaps the home range of another, so they share a landscape. Because it's a polygynous society from the male perspective, that means there's failed males out there that can't have access to mating with females. And we call those bachelor males, and they take over groups as males that are breeding males, the stallions, start to disappear. But the key to that society is strong bonds between males and females. And we want to understand why those bonds occur, because standing in sharp contrast to this society is the society of the Grevy zebras and the asses. There, the bonds among females are very weak, and therefore the bonds among males and females are even weaker. And we call those female groups that do form, they're very transitory. We call them open membership groups because animal A can be with animal B and C today, but animal A could be with animals X and Y tomorrow. So these groups are transitory. They break up on a daily basis. So what's a male to do? He's trying to maximize his evolutionary success by leaving lots of progeny into the future generations to spread his genes. And the females are not together in groups, he can't associate with those groups. So instead, he sets up territories, exclusive landscapes with boundaries so that other males can't come into his space. And in those territories are valuable resources for females, food and water in particular. And those females, if his territory is better than his neighbor's females, will cause females to linger longer in those territories. And so his reproductive benefits occur by being better able to own landscapes that are more nutritious and full of good water. And so as a consequence, he out-reproduces males that have no territories or males that have lower quality territories. Again, it's a polygynous system because one male will mate with many females. The longer they linger in his territory, the more likely he is to father and sire their offspring. But it's also a polyandrous society because, as you can see by the arrows here, the females will wander from male territory 1 into male territory 2, and therefore she has the opportunity to mate with one male and then another male. And the strong sperm competition that the second male to mate will often displace the sperm from the first male to increase his mating opportunities. Again, because it's polygynous from the male perspective, there's failed males out there. We call those bachelor males. So both societies have some commonalities and some specificities. And we're interested in why these two different types of societies persist, given that all the equids are members of the same genus, Equus, which means they're evolutionary, very close kins, sharing a lot of genes in common, and yet societally, they're very, very different. And so to get at this research, we often form partnerships. We work with other experts to look at genetics, to look at disease dynamics, to look at predation, to look at animal movements. But I would argue that, in fact, we need to bring the public into the equation as well, because we work on other people's landscapes. And as I've already indicated, my animals are considered vermin by the people who share the landscape with the livestock that the zebras want to feast upon as well. And so bringing them into the equation might do more good than harm, because they'll get to understand the dynamics, and maybe they're not as bad as they perceive them to be once we start looking at the interaction between livestock and wildlife. And so why do plain zebras and horses form uni-male groups and multi-female groups? Well, we can see here, if we look at the y-axis, interactions per female per hour, which is the number of aggressive interactions a female gets by a male who doesn't want the female to leave, or a male who wants to come in and try to steal a copulation from a female in a closed group. You can see that there's really no negative relationship with group size. So in other words, females that bond with a particular male have the same number of harassments by males on an hourly basis, independent of group size. If we look at the consequence of this in terms of grazing, that females that associate with a male, basically, regardless of group size, will feed about 75% of every hour. And there's no diminution of feeding as group size go up, which suggests that there's not strong competition, because if females were competing, you'd get a negative relationship. As group size goes up, the per capita feeding rate would go down. How does this come about? It comes about because the stallion that the female chooses to associate with is able, if he's dominant to other stallions, to reduce the harassment rate, because he's vigilant and is moving about, keeping the other males away. And so as a consequence, females with high-ranking males are herded much less per hour than females with low-ranking males. And this has the effect of giving females about 6 minutes per hour more time to feed, based on the male's rank if he's dominant. And since they feed 20 hours a day, they take cat naps periodically, but they're basically grass vacuum cleaners. They will be getting about 2 hours more grazing per day. They associate with high-ranking males rather than low-ranking males. And that means ultimately the number of surviving foals to the age of independence, which is 1, is much higher for females that associate with high-ranking males than low-ranking males. So this accounts for the pattern that we've seen in the plain zebras, that females are very choosy. They discriminate among males based on their ability to be dominant. And as a consequence, if they align with dominant males, they're less harassed, they graze more, and they can have more surviving offspring, passing more of their genes on to future generations. But if grouping with a male is so good, why don't the Grevy zebras and the wild asses do this? And we can see in the left picture here, mothers with young foals are standing out in the open. And what happens for the Grevy zebras, unlike the plain zebras, is that in plain zebras, every female, because of their small body size, has to drink every day. which means that there's no conflict of interest. Everybody has the same goals, the same physiological needs. But Grevy zebras are much bigger in body size, and females have different needs because the species itself is water independent. And what that means is females on average don't need to drink but every 3 to 5 days, unless they have a young foal that's less than 3 months of age, in which case they have to drink every day. And so we can look at distance from water, as shown in the next graph over here on the right, as a function of the dry season, the rains, early dry season, middle dry season, late dry season. We can see as the dry season expands over time, that if we put random dots on a map, we see that the watering points start to disappear because they dry out. And so the average distance of a water hole to a random point on the map increases as the dry season progresses. And we can see that non-reproductive females, those that don't have babies or have mature babies greater than 3 months of age, are essentially distributed randomly on the landscape because their points on the landscape are not much different from our random points when we look at distance from water. But those with young foals, less than 3 months of age, are much closer to water because they need to drink daily. And the males then that are setting up territories, the dominant ones put their territories near water, so they have access to the females with the young foals who have a postpartum estrus. In other words, they start cycling within a month of having a baby and they can get pregnant again. And those that are migrating back and forth from where they are grazing far from water, but they have to drink every 3 to 5 days. So they come through his territory and he has an opportunity to mate with them. And so because females have different needs, the social fabric among females is torn, which means males, to optimize their reproductive success, tend to distribute themselves in territories at different distances from water based on dominance. The dominants have access to both classes of female, those spontaneously ovulating every 3 weeks and those with a postpartum estrus. They gain access to the most females, and therefore they move away from bonding to any female to setting up territories, and at the best set those territories up near water. So that's what we've learned by looking at our long-term studies of equids on landscapes. And this applies Grevy zebras and wild asses, who also live in the most arid areas, tend to show this distance from water pattern, where those where it rains often, where it's mesic, where water and food are close together, there you get the closed membership groups because there's no conflict of interest. Everybody has to drink every day. So we started looking at this relationship between livestock and Grevy zebras because this water independent species live on landscapes where there are pastoralists. And the Grevy zebra is a species that's on the IUCN Red Data List as endangered. Our analysis shows that there's under 3,000 left on the planet. In fact, 10 years ago, there were probably less than 1,500 on the planet, hovering around 2,000 on average. And so across both Kenya and Ethiopia. So it's an endangered species, and we wanted to know why. And we wanted to ask the question, could it be because of the pastoralists also using this landscape by bringing their sheep and goats, which are growing in numbers because the number of pastoralists are growing. And livestock represents the means by which men can gain wives. It takes 10 cows to purchase a bride. Now you can see in this picture, in the distance, there's a chain link fence around this watering point. We've just shown that in the Grevy zebra, water is critically important because that's going to be necessary for females with young foals. If the daytime activity of the pastoralists are such that they're always at water, will the Grevies come in? And if they lock the water away at night by putting fencing around it, what is the Grevies going to do? So we asked, can livestock and Grevy zebras share a landscape? Now, I can bounce around this landscape in a Land Rover, but I don't know this landscape very well. But the pastoralists do. So we created a scout program with the support of the St. Louis Zoo, which gave us grant to be able to hire men and women in these communities to go out and sight the Grevy zebras while they did their ordinary activities. So women collect firewood and water and go into the bushy areas, and men do the herding, so they're up on the open grasslands with their herds. They were given a GPS, a handheld GPS, and they were given check sheets as seen here, and they recorded a bunch of metadata about the habitat. Was it open or closed? Were they near water or not? Were there livestock around? And if so, which species when they saw a Grevy zebra? Or were there other wildlife around? And then they counted the number of zebras, identified them by sex, and you can see the lunch pack here of the male. And you can see that anybody can do this. And they recorded males, females, adults, infants, juveniles, subadults, and they recorded what they were doing. Were they standing, walking, or grazing? And we compiled this data, did the statistical analyses, and then we came back every year and we, as a team, presented the data. So here's one of our female scouts presenting the data to the men who sat separate from the women. This is really important because this gives women very high value in the society, and the Garmin GPS actually gives them a lot of status and power as well. And they get paid $3 a day, and they work for us 3 days a week, so they make $36 a month. And we've now found out that the women use that $36 to buy tobacco, phone cards, and sugar to sell in the communities, and they can make up to $245 a month with the jobs that we pay them to do. And so they earn income, but their lives have been transformed in other ways. And so I just want to show you some of the data that we've amassed from the people. So this is in Swahili, and it says basically non-lactating females. And the Grevy zebra in Swahili is called Punda Kanga. Punda is the group of horses, zebras, and asses. And it shows two landscapes, the very fine grain, high quality landscape where the livestock are, and the coarser vegetation where the Grevy zebras are generally excluded. And you can see the balance is only about 30% of the Punda Kanga are seen with the livestock. 70% are in the poorer habitat. This is the breakdown that we do as scientists. We look at territorial males, bachelor males, non-lactating and lactating females. There's slight and significant differences, but you can see on average 30% of the sightings are with livestock and 70% are not. And we go and present the results to the communities. Now, the key here is the scouts own the data. The scouts gathered that data. We do the analysis, so they own the consequences of those analysis. They own the results. And so when we present this data to the communities, it causes concerns. They go, oh my goodness, 30%. And we start to talk about a whole series of issues with the communities, and the elders and the herders start giving us ways in which they might be able to adjust their behavior a little bit, but none of their solutions were going to make a big difference. And then we came back a year later and we presented the results. The warriors in this case said, Professor, we no longer throw sticks and stones at the Grevy zebras, and this is what the women do. And we don't put our dogs on them because they use dogs as early warning systems to detect lions when they're with their livestock. In fact, they were right. A year later, the sighting showed a 50% sighting of the Grevy zebra with the livestock. So something happened between 1 year and the next to radically change their behavior to become more tolerant of the Grevy zebras. And so now the landscape looks like this. Grevies and the cattle graze together. It is certainly a much healthier picture for the zebras, but it's turned out that it's a much healthier picture for the pastoralists as well. So here, going back 5 years, you can see sugar sales. 60 months before the present, there were no sugar sales. And now, 5 years later, the women are participating in selling sugar and increasing their income from $36 a month to over $285 a month. But what's amazing ecologically, so that's a social good, an economic good, because they invest in their children's health by taking them to doctors when they get sick and invest in their schooling. But what's really interesting also is that the stocking level of cattle has decreased. Now, there's been a general trend on grasslands to move away from the large animals, the cattle, to substitute sheep and goats because you can raise them more quickly. You can treat them as an ATM and sell one off and get some cash to join the Western society. And there's less likelihood they're going to get sick and die before you sell them. So there's ordinarily been a substitution. So seeing the cattle numbers decline, we weren't sure if that was because of our scout program or because of substitution. But notice what's happening. The goats and the sheep are declining as well. And the reason for this is that as women send their kids to school, especially their daughters, who are responsible for herding the sheep and goats around the manada or the homestead, that in school they can't do it. And if the women are busy becoming entrepreneurs, they can't do it either. So the number of sheep and goats are going down. So not only are their income levels going up, their harm to the environment is going down because stocking levels of livestock are going down. So we found it's a win for zebras, a win for scouts, and it turns out to be a win for the greater community because with money, the scouts pay back their debts. They spread their money as gifts on not just the immediate family, but their kin in the larger society. And so we're seeing it go out past the nuclear family of 10 individuals to hundreds of individuals. So we're increasing the wealth and the income of the community at large. So it's a triple win. Now let's turn to BioBlitzes, that I mentioned earlier, the Great Grevy's Rally. Here's some data on the history of Grevy zebras. The numbers were declining from when I started studying them in 1980, from about 15,000 down to about 2,000 by 2004. Worldwide, as well as in Kenya, because there are some in Ethiopia. And the problem is that the estimates were based on aerial flights and counts, which is a very poor way to get at the reliability of these animals because they hide under trees in the hot part of the day. And so we came up with the idea of doing a full species census using photos from volunteers. And because every zebra is naturally barcoded, and because I work with computer scientists using artificial intelligence, we can use stripe recognition to identify individuals. So we can do a mark recapture without having to mark the animals because they're naturally barcoded. We can do a site recite. And so we gathered together over a weekend 350 members of the public, the growing middle class from Nairobi, the Conservancy members as shown by this one female scout here, rangers and scouts from the conservancies, the national parks and reserves, county government officials who worked on their own free time over the weekend, KWS, the Kenya Wildlife Service, zookeepers from the St. Louis and the San Diego Zoo and zoos in England, and independent scientists like me, as well as the US ambassador to Kenya. So we created a real citizen science public participatory project to actually answer the question, how many really are there when it's hard to count them, to come up with a number that's believable? Because if you're going to have governments providing action plans and policy, they're going to have to believe the numbers. Now, the Grevy zebra is hard to measure, hard to study. They range over 25,000 square kilometers across 5 counties. Well, our stripe recognition algorithms are embedded in Wildbook. And if you want to go explore that, go to wildbook.org, one word, wildbook.org. And you'll see that we work on whale sharks and a whole bunch of other species as well. Well, the first year we did this in 2016, we did it again in 2018, and we've done it again the third time in 2012. We started out with our 350, we're up to 500 volunteers now. And our 40,000 photographs are now up to 80,000 photographs, covering 5 counties and the 25,000 square kilometers. This was monumental and historic, but it is total public participation. First, we had to train the trainers on how to use the GPS-enabled cameras that the National Science Foundation in the US gave us as a supplement to our grant to study these species. And then they went out and gave every team some swag, a bag, a camera, as well as these little QR cards, which they took a picture of, which allowed us to synchronize all the cameras. Because if they used their personal cameras that didn't have GPS, they had to be synchronized with our cameras in the vehicle that did have GPS. And most people don't even bother to set the time on their cameras. But with the QR code, 3, 2, 1, snap, everyone taking the same picture at the same time, we could then tune all the cameras to the same time. And what we did is we drove randomly in counting blocks, 45. We divide the nation up to 45 counting blocks. People drove around, took pictures of zebras, be they adults or students. And then we used our Wildbook software to identify hotspots on the zebras. And stripes that are parallel don't have a lot of information, but when the stripes crisscross each other, if you can see my fingers here, then they cause what I call hotspots, high areas of entropy. And our algorithms will find similarities of these hotspots and give us a score. And we can then determine whether the animals are the same. So these are the same animals seen at 2 different sightings in 2 different locations at 2 different times. And this allows us on day 1 to identify unique individuals, and then on day 2 to identify another set of unique individuals, of which a fraction will be the same animals seen on day 1. And from that, mark recapture statistics allow us to estimate the population. And then we present the results at the yearly black and white ball, which bring together all of our scouts for a fancy dinner, and we then share the results to them who got the data, as well as to the government officials who manage the species. And this is the type of data that we get. In the nation, our first estimate in 2016 showed there were 2,350 plus or minus 93 for a confidence limit. Very tight confidence limits, which meant the government believed our numbers. And then despite 2 droughts intervening between 2016 and 2018, the numbers went up to 2,812, again with a tight confidence limits of 163. You can see nationally the numbers improved, but they also improved by county. And part of the reason was that in these 2 counties, we didn't have a lot of people sampling in the first year, but in 2018 we did. And so the numbers went up there. But you can see in each county they went up as well. Now, why did they do this? Well, they did this despite the fact that the number of babies surviving went down. So we've done some mathematical models on population viability analysis type models, and we show in our models that if 30% of the population are recruits, infants and juveniles, the population will sustain itself. And you can see nationally, in 2016, the population was at 30%. We turned the corner. This was especially true for Samburu and Laikipia counties, the heartlands. And then in the counties where they're not that common, 2 out of 3 were doing pretty well. Meru was doing very poorly. But Meru, you can see, started to improve by 2018, whereas the other counties, the number of recruits were way down. And the reason for this was droughts. This is what the Kamanjo Naibunga Conservancy looks like today, but it usually looks like this, and during droughts, it looks worse than this. And what happens during good times, when a baby survives, is the mom skips a year because she's got to raise that baby, and her postpartum estrus doesn't implant. But when you lose a baby, then that postpartum estrus gets you pregnant and you can breed again. And if the next year it rains, you really don't lose time. You make up for the baby you lost very quickly, and the population can grow. And that's what was happening during the droughts, because this is what the landscape looked like by April 2018. Grass everywhere, and you can see these 10 females all have 10 foals less than 10 months of age. And so we think by 2020, the analysis we're doing now is that in fact, the adults weathered the storm of the drought, and now they're rebounding with lots of babies. But we couldn't do this without the public massively sampling the animals all over. And the governors who participated in the project with their staff now see and understand the dynamics, and they're making, they realize they are managing this iconic historic species that defines Kenya, and they want to make a difference. And the cabinet secretary, Patrick Amundi here, the deputy secretary, received our results at the black and white ball, and he accepted the numbers for the first time, taking numbers from not Kenya Wildlife Service employees. And you ask him why, he said, how could I not take the numbers? The public generated the numbers. Our people generated the numbers. So we're connecting science to society. Third, we now worry about the next generation, and we've created conservation clubs. Support, again, by St. Louis and San Diego Zoo, provide us with a way of bringing the students into the process of connecting to science. Now, the Kenyan educational system is one of rote memorization and repetition. But we gathered teachers and family members at a workshop to create what they wanted in a conservation curriculum. They created 5 domains that they wanted their children to study better. And we did that, and we created experiential learning, which starts with a lecture demonstration or a story. We play games that simulate what goes on in the real world. This is a game called On Guard, where we look at the benefits of group living by having one zebra out alone with a clothes peg on her back, and each of these students get tapped randomly to be a lion. The student has to call out the student's name before the clothespin is taken off the back, in which case they escape. If they're not, then they can't, then they die. But once we do this game, we can show that about 80% of the time the single zebra gets eaten. But once you have groups of 3 students working together, so you have many eyes looking around, and they're also getting stones, eating the grass, so they're being not vigilant when they're grazing. Once they're in groups of 3, they're almost never successfully attacked by lions. So we teach them fundamentals of the benefits and costs associated with group living. Here, a student, after going on a bus drive and learning about the behavior of animals, was going to act out. He got a little piece of paper like charades and said, "Be a zebra dust bathing," and the students had to guess what he was doing. So again, it's experiential learning, learning what wildlife do, how wildlife interact on a landscape. And now we have many games that also bring in the relationship between livestock. We have a community conservation day where students come and they act out dramas that they create. We do camera traps as one of the activities, so they can look at the different abundance of wildlife on different habitats depending on grazing intensity, and they can share the results as they do here with the community at large. And here are some of the results that they find. We also have indigenous knowledge. The teachers and parents said, but the landscape has changed and our students are not connected to the landscape. Sounds familiar, doesn't it? And so we had them go out with an elder to the elder's favorite place and describe it. And they had to draw it as it was then, as it is now, to understand landscape changes. We have them play games of hypothetical what if, more or less game. If there's more people, what does that do to grass? If there's less grass, what does that do to livestock? If there's more livestock, what does that do to wildlife? And no 2 games ever go in the same way. And so we're investing in teachers locally to make them able to teach experiential learning. So our philosophy fits this Chinese proverb: tell me and I will forget, which is their typical lecturing and memorization system of learning. Show me and I'll remember. Involve me and I will understand. And step back and I will act. Our job is to teach the teachers how to teach, not have us in the classroom in the future, and let us stand back and let them act on their own behalf. And we do this locally with our own teachers in the schools down by the Pine Barrens and around Princeton. We have Quest, which is questioning underlies effective science teaching. We have workshops. We read about a problem. We identify patterns. We ask questions. We gather and analyze data. And they present to each other, as well as the subject area supervisor in the school, as well as the state administrators that affect the curriculum statewide. We've worked in Barnegat Bay. We've worked on Hawk Mountain in Pennsylvania. We've looked at diamondback terrapin nests in Barnegat Bay. We've looked at terrapin vision to see how they see the world because they get hit by boats. And so we change the question each year and change the study system as well. But I just want to show you a Wordle from the teachers in our questionnaire before and after. So we asked the teachers, what did they expect before they did the workshop quest and after? And I highlight what they were interested in. Before, they were interested in questions, and afterwards they learned about, they were interested in asking questions, but they said they wanted to learn skills and knowledge. Afterwards, what highlighted to them most was research and the process of science. And so they go in knowing it's about questioning. They feel they're going to come away with skills and knowledge because that's what they want to teach better to their students. But they stand back and start to realize that research involves questioning, but it's really about a process. It's about a process of knowing. So I'm going to end with Gilbert White's Natural History of Cell Burn in 1787 was, if a writer should at all appear to have induced any of his readers to pay more ready attention to the wonders of the creation, too frequently overlooked as his common occurrences, his purpose will be fully answered. Remember, he was a minister. My purpose would be to fully answer this question if my remarks to you were to empower people to engage with science so they can better understand the world around them, democratize science, and improve their well-being and that of others inhabiting the planet for both people and wildlife. If we can do that, people and scientists will work together for both environmental and social good. Thank you very much. So now I'll take some questions.
All right, thank you. That was a really interesting presentation, and I see some more people have joined us in the process. So, does anyone want to ask a few questions here? And if you want, you can type questions in the chat. If you don't want
If
to.
you're shy, we can look at the chat, but feel free to speak up. I see you put wildbook.org. Yeah, you'll see that'll take you to what we're doing with stripe recognition. If you want to see the landscape I work on, go to impalalive.org. Okay, I'll
Impala Live? Okay.
Yeah, MPALA live.org. And there you'll see the hippocam that's live. And under classroom, you can see the curriculum guide that I talked about. Under storytelling, you can see some of the stories. We created a reading corner for elementary school students this year, and you can see some stories from the bush.
Diane's asked a question, and I do get this problem with ecology class. A lot of people are afraid of going outside. They're afraid of ticks. They're afraid of things falling on them. And how do we counteract the media that has made people more afraid of going outside?
Well, it is true that, we have been disconnected from nature, and that we are scared to go outside because we're worried that these ticks are going to get us or a tree's going to fall on us. I would say start with your backyard. You look at the birds in your back garden. You know your back garden. You cut the lawn, you till your garden. And so that's pretty safe. So this year, because of COVID, I taught the Quest course because I didn't go to Africa. Normally, I just advise on it. And I did it with squirrels in the backyard. Okay. And so I designed some projects to work on how do squirrels manage risk. We're in the time of the pandemic, so we're all concerned about risk. Should we wear a mask? Should we travel on a plane? Do we go to the grocery store? These were really burning questions when we didn't know much about the disease back in March and April. So I taught the course in June, and I said, we're not going to answer that question yet. We're going to let the squirrels teach us how they manage the life dinner principle. Everyone needs dinner to survive till tomorrow, but you can fast. And in fact, if you're on a diet, you're going to fast. But if you get eaten, you're done. And so you're balancing predation risk against starvation. Should I forego a meal? Should I go out into a dangerous area to get that next acorn? Or should I say, forget it, I have enough to get me through to tomorrow, not enough to get me to the next day, but that's okay. It's just too risky. And does risk change with time of day and stuff like that? So you can start in the backyard. Watch your animals. Start to see pattern and process. And once you realize that in your backyard, yeah, you can put mosquito repellent on and keep the mosquitoes away. And yes, you'll get ticks, but you know that you can feel them crawling on you, or you can put some anti-tick lotion on, and you'll get more confident to be able to go to the park. And from the park, you'll go into the denser woodlands, and the world will unfold around you. You'll start to go to lakes and rivers and see the diversity of life, because you will become more confident in your ability to overcome these concerns, and you'll have a desire to go connect with nature that's more diverse than your backyard. So take it in baby steps and expand your horizons.
I think that's perfect because this week my students were working on survivorship curves too. So you're talking about the
Okay,
squirrel
yeah,
there, so
exactly.
fits in perfectly. Um, I think some of the students are probably having to rush off to other things,
Okay.
but we've got.
Yep. So there's one that says, as an advisor rather than a science major, this was great and super interesting presentation. Also, it's helpful to learn to be able to speak with students interested in environmental studies. Thank you. Well, I'm glad it resonated, because I'm a firm believer that we as scientists look at the world critically, but we have a responsibility to share that with others. And we have a responsibility to ask people to join us at whatever level they want, because by doing science, you really understand science. And if you understand science, you become a champion and ambassador. We often call our programs in Kenya building champions, building ambassadors. They get to know the species and they get to understand what the real consequences are of sharing. You know, the zebras can bring disease in to the area, but they can also, we've shown, eat the stems and the straw, which the cattle can't stand because they get poked in the face. That lowers their intake rate. But with the stems and straw gone, we've shown experimentally that the cattle grow faster. So what is perceived as competition actually sometimes is a mutualism. Okay, as long as the soil moisture and grass grows, once the stems and straws gone, leaf diversifies, leaf becomes more abundant, and cows love leaves. And they love forbs that grow in and amongst the leaves. And so once the zebras take away the annoying parts of the plant that are not nutritious, the cattle have a field day. And so that's a mutualism rather than a competition. It dispels a belief system that they had to shoo the animals away. And that's why they start letting them come to water. And that's why they let them share the landscape. And that changed their behavior.
I read a paper about tigers in India, and they had the same problem, that the local people were afraid of them eating their cattle. But they found that when the tigers were around, they kept the other predators away, and they actually lost fewer cattle when the tigers were in the area than when the tigers had been absent and had been scaring away everybody else. So these
Right. And
interactions.
Exactly. And the pastoralists now start to see that the Grevy zebra anticipate drought that they don't anticipate. So when the Grevies abandon the locale, because they come around the homestead at night for protection, because human activity keeps the lions away, once they disappear, that now becomes the canary in the mine. Uh-oh, the Grevy zebra has disappeared. Bad weather is coming. We better start anticipating moving our cattle to where the Grevies go. And so they're now seeing the Grevies as an early warning system. So this vermin is showing them benefits that they never had before. They're learning to read their landscape differently by participating with us in our studies.
That's really interesting. I like getting the public involved, and we've been forcing our at least our ecology students are being forced outside every other week to collect some data, even if it's no further than their own backyard and looking at the weeds. We'll have to do squirrels next time, right?
Yeah, squirrels are great. Yeah,
Yeah.
there's some really interesting things you can do, because you can walk at them and drop socks and measure detection distance and flight distance in different habitats at different times of day. You can put out feeding trays and see how many nuts they take in different habitats at different time of day. They're titrating their risk, because if it's dangerous, they don't take very many of them. If it's safe, they take lots of them. So you can get the landscape of fear just by their behavior. Right.
That's
And
really
so this
cool.
is how you can then manage, you can generalize from that to issues of how do we manage risk? Do we go into supermarkets? Do we go early in the morning if you're a senior citizen? Yes. Do you care? Do you wear a mask to protect yourself and to protect others? How are you balancing your risk against your other needs?
Does anyone want to ask any more questions, Kira?
In regards to research, I know that the world is so big and so diverse. Do you have any advice on how to approach doing research in a specific animal? Like, what influenced you to pick Grevy zebras?
Well, I actually started on horses. Okay, so I like mammals, and I started on horses, and I went to Duke University, and Shackleford Banks is an island off the coast of North Carolina, like Chincoteague and Assateague, which you probably know more of because that's where Misty of Chincoteague comes from. And it's the same horses. And I was going to go study them. And the Park Service said, don't bother, young man. We are going to buy that island from the state of North Carolina. I'm going to kill all those horses. So I said, oh, okay. And so I did my thesis on pygmy sunfish in the green swamps of North Carolina, looking at mechanisms of competition and how they communicate. But I never lost my love for the horses. And I started a side project on the horses. After I did each of my experiments on the pygmy sunfish, we glanced at 180 days. I needed a break. I'd go live on the island. The horses are still there. Now, they're still there because a librarian from Cherry Point, a marine base, called me one day and said, they want to kill the horses. Will you help us preserve the horses? That's a different story. But I was interested in horses because of the following. They're like humans, they're neolocal. What that means is that sons and daughters leave home. That is a rare mammalian mating system. Most are philopatric by one sex or the other. And so in birds, sons stay with their fathers and females disperse. In mammals, generally, daughters stay with their mothers and sons disperse. And that prevents inbreeding, which means that you've got kinship. And if you're going to look at the evolution of altruistic behavior and cooperative behavior, it's discounted by sharing the same genes. It's easier to get social living when you've got relatives nearby. So I was intrigued by horses not having any relatives being highly social. That's what got me interested in the project. And then I worked on horses, came up with the rules that I talked about, but there were no predators. How general were my rules? And that took me, I had a postdoc in England. From England, it was easy to get to East Africa because England and Kenya had relationships. And so I went down there and added predators to my study. And my rules withstood the existence of predators, which are not that important actually, for a lot of these social things. It's very important for movement, but not necessarily for their society. But nonetheless, that's how I got interested in zebras. But I started with horses because I was interested in a deep conceptual problem, which is how do you get social living among strangers? Okay, and that came from natural history. I was on that island all the time swimming because I taught marine ecology in the summer, and therefore I was able to go out and enjoy the island. There were horses there. And so I started getting interested in horses because of that, because I started looking at them. And then that got me into this aha moment, but they're strangers. That's an interesting question. I wanted to do that for my thesis, but I wasn't allowed to. I did something else. But I did it as a side project, and I've continued on with horses, zebras, and asses. So I do the asses in Israel. I do the true wild horses in China, and I do the feral horses in the United States.
All right, thank you. We really appreciate you taking the time, and I know you're extremely busy. If people wanted to reach out and ask further questions, is there a way
Sure, they can reach me at DIR, my initials, DIR at princeton.edu. So I can put
That's
that
easy. I'm just putting it in the chat.
Yep. Okay.
All right. Well, thank you so much. We really appreciate you taking the time. Enjoy our last of our warm weather today.
Yeah, exactly. It turns on Sunday. We get back in the 50s, and then my phone shows it going down from there.
All right.
All right.
And
So,
everybody else
hope
is
you
going to spend
enjoyed.
some time looking at squirrels.
Okay, very good. Bye, everyone.